Hello YouTube, Ryan here. About a year ago, I built this 2x72 grinder, and at that time there were some people on the forums that were interested in a work in progress, and unfortunately I didn't take pictures of the steps that were involved, so I thought that I'd make a quick video for you guys. And my hope is that maybe someone that wants to get into knife making but can't afford the grinder like I couldn't can get some ideas from this and maybe build their own machine, because the total cost for this entire project was about $48. And the only things I actually had to buy were these 2-inch longboard wheels with bearings, the nuts and bolts that you see, and these two filters. And a lot of people told me that this wasn't going to work, and they told me that if I was dedicated I would spend the money, and I was trying to cheap out, but that's really not the case. I couldn't afford the grinder, so I had to do what I could with what I had, and it actually turned out pretty good because I've used it for a year now, and for the last 3 or 4 months I've used it nearly every day, and I've never had an issue with it. No issues. And let me go over some of the features real quick here. Inside of this box there's a 2 horsepower treadmill motor, and I know those horsepower ratings are fictitious, but with that 3.5-inch drive wheel that's on there, the machine runs at about 5,600 feet per minute. And even at that speed, the only way you can bog it down is if you're putting all your weight into whatever it is you're pushing into the belt. So it's never been an issue for me. The flywheel that was on the treadmill I removed on the motor, and it's a threaded shaft on the motor, and it's a left-handed thread, and you probably could find nuts for it, but what I did was I cut the threaded portion off of the flywheel with a hacksaw while the motor was spinning, and then I kind of turned down the piece that was left while this was running and made a nut. And there's one on the back side and one on the front side of this wooden drive wheel that hold the wheel in place. And because the treadmill motors are open framed, I had to build this enclosure, and it's just really simple steel sheet metal enclosure riveted together, the wooden top so I can remove it. This filter here is the outlet filter. This filter back here, somewhere over here, is the inlet filter, and inside is an exhaust fan from a range hood and an oven that I got for free. My friend had it sitting in his shop, and I can run this grinder all afternoon and it doesn't overheat. The treadmill, the whole treadmill I got for free, which really isn't all that uncommon because people buy them, they don't want to use them, they throw them out, or they sell them dirt cheap. So even if something happens to that motor or the controller, I can pick either of them up for 40 bucks. So it's really not that big of a deal, but like I said, it's lasted for a long time now. I kept all the electronics from the treadmill, and I replaced the sliding speed controller that connects to the motor controller. I replaced it with this potentiometer. I think it was a 2000 ohm potentiometer, and it came out of an amp. One thing real quick on the motor controllers, some of them will have the I forget what they call it, but it's a magnet that reads the speed of the motor, and it won't work correctly without that assembly. And this one uses the MC60 motor controller. You can get them for 40-50 bucks on eBay, and they don't need to have that. So that simplifies things. That's an obstacle a lot of people have when they're trying to do this. This switch here was going to be forward and reverse for the motor, but I ended up not needing it, so it actually doesn't do anything. This switch here, however, controls the incline motor for the treadmill, which I use for the belt tensioner. You can see it connected through this bolt here and this bolt down here, and it pushes up on the tension arm to put tension on the belt. And a lot of people told me that was overcomplicated. It wasn't going to work, but like I said, I've had no issues with it either. I built an enclosure for this, but I didn't end up putting it on there. Every once in a while, maybe like 4 times now, I've vacuumed that little motor out, and it's been okay. The reason I wanted to use this was because unlike a spring where the tension's variable, the harder that you pull on it, And unlike a spring that bounces, this is rigid. This uses you can see one of the teeth here on the pinion. It uses a rack and pinion system and gear reduction, and it's all included in it. And you can stand on this when it's fully extended and it doesn't move. It's designed to hold the entire, walking platform of the treadmill up, so it's plenty strong enough. And all the steel components you see were just structural steel left over. You can see that my shop's built out of the same stuff, and that was all stuff I found sitting around here, and remnants from that. I think it's 16 gauge 2x4 steel. Tool rest was a piece of scrap metal that my neighbor had. Now, don't judge me on the welding. That was my first time welding, so we won't talk about that. We'll go over to this side. That side is not only darker, but it was the second time and it looks a little better. But you can see the bolt goes through these two pieces so that you can tip the tool rest back and forth so that I can clamp my blade to a piece of angle iron and keep my bevels precise. Guess I'll turn it on for you guys real quick, show you how. The tracking mechanism, also really simple, just a piece of all thread with the handle welded on it, nut welded onto there. You can see how it works. You tighten it down, it pushes on this, and the hinge, which is actually both of these hinges are polished rod clamps from an oil field parts manufacturer I was working for at the time, and they were scrap. But honestly, I think it'd be a better option just to make your own hinges. You can see these had some slop in them, so I had to build this and these pieces here to keep everything square while it's moving. But I guess I'll run it for you guys real quick. There's a light switch down here to turn it on. That fan's really loud, so I hope you can still hear me. But one nice thing about the treadmill controls is that I have variable speed. I can have it barely moving like this, or I can have it going the full 5,600 feet per minute. Here's a old rasp. You can see it takes it off there fairly quick, and power isn't an issue. The tool rest is removable. Loosen this, and it slides out. A lot easier to do with two hands. The belt changes are easy. You can do it one-handed. Push the button, arm lowers, take the belt off. That's all there is to it. And I was going to put originally some kind of a scale here so I'd know exactly when I had 35 pounds of belt tension, but honestly, I haven't needed it. I raised the arm up, I raise the arm up until the belt feels like it's tight enough, and that's how I use it. So if there's anything I missed, any questions for me, anything I can help out with everything I learned on this, then leave a comment down below, and I'll do what I can. Thanks, guys.